Good evening, everybody. I mean, it's now the middle of the night, going into the early hours of the days, but I am about to use trig identities to find the exact value of the tangent of 5 pi over 12. Now, there's a couple different ways you can approach this. You can use the traditional trig identity for tangent here, or you can use it as sine over cosine. I'm going to attempt this using this one first. So, let me get a new sheet of paper for that. This is going to be math. But first, let me convert 5 pi over 12 into degrees. So how I do that, 5 pi over 12 times 180 over pi. I need to put my phone down for a minute so I can calculate this. $75 degrees. So this should be 75 in degrees. So could that be 30 plus 45 degrees? Yeah. And in radians, that would be pi over 6 plus pi over 4. And we're taking the tangent of that value. So, we're going to try it this way first, using the sine identity over the cosine identity, because tangent is sine over cosine. This is how I like to treat tangent of a plus b as plus or minus b, perhaps. And this indeed is equal to sine of a plus or minus b over cosine of a plus or minus b. I mean, you can treat the actual trig identities the same way. So, if I treat it this way, this is going to be the sine of pi over 6 plus pi over 4 over the cosine of pi over 6 plus pi over 4. I mean, it would be a lot faster if you approached it from this traditional identity, but I'm trying a different way to approach it. I don't think I'm going to be able to fit this all on this one page. This is probably going to be a math war, so be advised. So it's sine, cosine, cosine, sine for the numerator. All right. So that was. So what do we got? We have sine of pi over 6 times the cosine of pi over 4. And I think we're adding, right? Yeah. Yep. So plus cosine pi over 6 sine pi over 4. And then in the denominator, we have cosine, cosine, sine, sine. And you got to be careful of cosine because the sign does change. That's why it's minus on top. So we've got the cosine of pi over 6, cosine pi over 4 minus, because the sign changes, sine of pi over 6, sine of pi over 4. Now it's just a matter of simplifying. So the sine of pi over 6 gives me 1/2. The cosine of pi over 4 gives me the square root of 2 over 2. And I add that. Cosine of pi over 6 gives me the square root of 3 over 2. And the sine of pi over 4 is just an easy square root of 2 over 2. And then in the denominator, cosine of pi over 6 is the square root of 3 over 2. Ooh, complex fractions. Yay, this is going to be fun. Cosine of pi over 4, square root of 2 over 2, minus sine of pi over 6, which is 1/2, sine of pi over 4, which gives me the square root of 2 over 2. And then simplifying, here, you know what, I'm going to put this in order. So the square root of 6 plus square root of 2 all over 4 all over square root of 6 minus the square root of 2. Oh, sorry. That should be the square root of 2 all over 4. And guess what? These 4's cancel out. And I'm left with the square root of 6 plus the square root of 2 all over the square root of 6 minus the square root of 2. And this is the exact value of tangent of 5 pi over 12. That's one way to approach a problem like this. Now, I'm going to do it with the traditional identity in a different color. Blue works. Okay. So, in order to find the tangent of 5 pi over 12, using just the traditional formula for the tangent, which is tangent A plus or minus tangent B, and I said this was the tangent of pi over 6 plus pi over 4. So just using the traditional identity, I have tan pi over 6 plus tan pi over 4 over 1 minus, because the sign changes, tan pi over 6 tan pi over 4. Okay, so I'm kind of picturing the graph of the tangent of x in my head. It has a vertical asymptote at 0. That's why the tangent of 0 is undefined. No, the tangent of 0 is 0. So the tangent of pi over 6 would be the square root of 3 over 3. Yeah. Tangent of pi over 6 is the square root of 3 over 3. Plus tangent of pi over 4, which I know is 1. Easy enough. And we have over 1 minus root 3 over 3. Tangent of pi over 4 is just 1. So that is going to give me... And if I need a common denominator, I'm going to rewrite this as 3 plus the square root of 3 all over 3 all over, that's just root 3 over 3, so this should be 3 minus root 3 all over 3. And these 3's cancel out. So I am left with 3 plus root 3 all over 3 minus root 3. And I believe that can reduce. And I believe that can be just 1... I'm going to try it this way. 1 minus root 3. Let's see if I'm right. So the tangent of 5 pi over 12. And I said 1 minus... Oh. Dang it. 2 plus root 3? I was close. What did I do wrong here? What did I do wrong here? See, my calculator says 2 plus root 3. I should at least check the tangent of pi over 6. Be sure I'm right on the square root of 3 over 3. Yep, I am. And the tangent of pi over 4, that should be 1. Yep. Well. See, this should be a plus. You know what? Tangent of 5 pi over 12. Oh, you know what? Because this is a 3 over 3, and this is also a 3 over 3. Well, I did just use the trig identity. Oh, you know what? I think the traditional trig identity fails, because, yeah. if it's 2 plus the square root of 3, then yeah. I'm going to agree with what the calculator says on 2 plus root 3. And I'm going to check in the calculator to see if my sine over cosine thing didn't fail. So 2 plus root 3, that's approximately 3.73. Is that going to give me approximately 3.73 as well? Yes. You know, I think my sine over cosine method didn't fail at all. Because look at that. It even works with trig identities. It's really the traditional identity that failed me. So there you go, ladies and gentlemen.